Greetings and a warm welcome to the channel. I am truly happy that you have decided to join me here. Perhaps you have just finished a long, exhausting day, or maybe you simply find comfort in drifting off to sleep while pondering the stars, distant galaxies, and the silent enigmas of the cosmos. No matter what brought you here, the voyage we are embarking on tonight is designed specially for you. There is absolutely nothing you need to accomplish or worry about right now. Simply allow your body to settle into a state of rest. Let the rhythm of your mind begin to decelerate, and permit your thoughts to float away. This evening, our focus is on exploring the sheer magnitude of the universe itself. We will not be limiting our view to a single star system or a solitary galaxy, but rather, we will look at the entire, ever-growing cosmic tapestry. Our journey will transition smoothly from one fascinating reality to the next, as we discover the secrets of black holes, primordial radiation, invisible dark matter, and isolated islands of stars across the deep night. A few of these insights might astonish you. Other concepts might linger gently in your mind, like a soft, peaceful realization on the brink of slumber. If these tranquil journeys into knowledge assist you in finding rest, you are always welcome to hit the like button and subscribe. Doing so makes it easier for other wandering minds to discover this peaceful space as well. Now, whenever you are fully comfortable, let us begin our journey. The cosmos might actually possess a much greater age than we previously calculated. The majority of contemporary scientific calculations position the birth of our universe at roughly 13.8 billion years in the past. This specific calculation is derived from meticulous observations of the cosmic microwave background radiation and calculations tracking the speed at which the fabric of space is stretching outward. However, not every astronomical strategy yields the identical result. Certain detailed examinations of incredibly ancient stars and primitive galaxies indicate that they could potentially be older than that traditional 13.8 billion year timeframe comfortably permits. Various researchers are raising questions regarding our assumed velocity of cosmic expansion, while others propose that the behavior of dark energy might be shifting across vast stretches of time, making our standard calculations somewhat imprecise. If the universe truly is older than we think, it could fundamentally alter our comprehension of how the very first stellar structures and galactic networks managed to develop so rapidly after the dawn of existence. It forces us to realize that the cosmos has been quietly sitting in the darkness for an unimaginable span of time, holding secrets that we are only just beginning to unravel. Consider the sheer scale of 13.8 billion years. It is a duration so immense that human minds cannot truly grasp its depth. To make it easier to visualize, let us imagine compressing the entirety of cosmic history into a single calendar year. In this cosmic calendar, the cataclysmic event of the Big Bang takes place precisely at the first second of January 1st. For months afterward, the universe remains dark, hot, and empty of life as we understand it. The planet we call home does not even begin to coalesce until late August. The earliest complex organisms do not emerge from the primeval oceans until the final weeks of December. Famously, the entire documented history of human civilization, every empire that ever rose, every war that was ever fought, and every life ever lived, occurs within the final seconds before midnight on December 31st. This perspective reminds us how brief our presence is, yet how profound it is that we can look back and piece together the story of the cosmic dawn. Let us turn our minds toward the earliest illumination to ever shine through the emptiness. This phenomenon is recognized by scientists as the cosmic microwave background. For roughly 380,000 years following the initial expansion of the Big Bang, the universe was an intensely hot, opaque soup of plasma. Light was completely trapped, unable to travel any distance without colliding with free electrons. It was a realm of absolute fog and blinding heat. But as the universe continued to swell outward, it gradually cooled. Eventually, the temperature dropped to a point where protons and electrons could bind together to form the very first neutral atoms of hydrogen. This monumental epoch is known as recombination. Suddenly, the cosmic fog cleared, and light was set free to travel across the vast openness of space for the very first time. That original glow has been traveling through the void ever since, stretching over billions of years into longer, cooler microwave wavelengths. Today, this ancient light bathes the entire cosmos in a faint, invisible shimmer, acting as a direct echo from the dawn of creation. When we observe the sky with sensitive radio telescopes, we can detect this ancient radiation coming from every single direction in the heavens. It is incredibly uniform, yet it contains minuscule variations in temperature. These tiny fluctuations, measuring only fractions of a degree, represent the original seeds of matter. They show us the subtle ripples in the density of the early universe, where gravity would eventually pull material together to construct the very first stars, galaxies, and planetary systems. Without these microscopic imperfections in the early plasma, matter would have remained perfectly smoothed out, and the universe would be an empty, featureless void today. Instead, those small variations allowed the rich, complex structures of our modern night sky to slowly take shape over billions of years. Consider the immense, enigmatic presence of dark matter. When we look out into the night sky, everything we can visibly see, every glowing star, every swirling nebula, every massive galaxy, and every planet, makes up a mere 5% of the total matter and energy in the universe. The vast majority of the cosmos is entirely invisible to our eyes and our most advanced instruments. Approximately 27% of the universe is composed of dark matter, a mysterious substance that does not emit, absorb, or reflect any form of light or electromagnetic radiation. We only know it exists because of its immense gravitational pull on the visible matter around it. It acts as an invisible scaffolding, a cosmic glue that holds entire galaxies together. Without the immense gravitational net cast by dark matter, galaxies would spin so rapidly that they would fly apart, scattering their stars across the empty intergalactic wilderness. Astronomers can map this invisible matter by observing a phenomenon known as gravitational lensing. Because dark matter possesses mass, it warps the very fabric of space-time around it. When light from an incredibly distant galaxy travels toward Earth and passes through a massive clump of invisible dark matter, the path of that light becomes bent and distorted, much like light passing through a glass lens. By carefully analyzing these distorted images of distant galaxies, scientists can calculate exactly where the dark matter is concentrated and how much of it is present. It is a testament to human ingenuity that we can map the unseen structures of the cosmos by simply watching how they alter the paths of traveling starlight. Let us now reflect on the concept of dark energy, which is perhaps the most profound mystery in all of modern science. While dark matter acts as a cosmic glue trying to pull things together, dark energy behaves as a mysterious force that pushes everything apart. It makes up roughly 68% of the total composition of the universe. For a very long time, astronomers believed that the gravitational pull of all the matter in the cosmos would slowly decelerate the expansion that began with the Big Bang. They thought the universe might eventually slow down to a halt, or even reverse and collapse back on itself. However, in the late 1990s, scientists measuring distant exploding stars discovered something completely unexpected. The expansion of the universe is not slowing down at all, it is actually accelerating. Something is actively driving the fabric of space-time to expand faster and faster with every passing second. This accelerating force is what we refer to as dark energy, and its true nature remains almost completely unknown. It is smoothly distributed throughout all of space, and its influence becomes stronger as the universe grows larger. As more space is created, more dark energy appears to fill it, while regular matter becomes increasingly diluted. If this acceleration continues unabated, it will dictate the ultimate fate of our cosmos. Billions of years from now, Galaxies will be pushed so incredibly far apart from one another that their light will no longer be able to reach us. The night sky will slowly grow darker and emptier until every galaxy becomes an isolated island, completely cut off from the rest of the cosmos, floating alone in an infinite, cold abyss. Let us guide our thoughts to the first generation of stars that ever illuminated the darkness, known to astronomers as Population 3 stars. These were cosmic titans, entirely unlike the stars we see in our night sky today. Because the early universe contained only the simplest primordial elements, hydrogen, helium, and a tiny trace of lithium, these first stars were forged from pure, unblemished material. Without heavier elements to slow down their gravitational collapse, they grew to monstrous proportions, often reaching hundreds of times the mass of our Sun. They burned with an intense, hyper-bright blue light, shining with a ferocity that has never been matched since. Because they burned through their nuclear fuel at such a frantic, accelerating pace, their lifespans were incredibly brief, lasting only a few million years before ending in spectacular supernova explosions. These cataclysmic deaths were essential for the future of the cosmos. Deep within their scorching nuclear furnaces, these massive stars fused simple hydrogen and helium into heavier elements like carbon, oxygen, silicon, and iron. When they exploded, they scattered these newly forged elements across space, seeding the primordial gas clouds with the raw materials needed to build more complex structures. Every single atom of iron in your blood, every breath of oxygen you take, and every grain of silicon in the sand beneath your feet was manufactured inside the heart of an ancient star that died billions of years ago. We are, quite literally, made of starlight. Now, picture the astonishing variety of planetary worlds that exist beyond our own solar system, hidden among the stars of our galaxy. Astronomers have confirmed the existence of thousands of these exoplanets, and many of them are stranger than anything found in science fiction. Imagine a world named 55 Cancri, which orbits incredibly close to its parent star. The surface temperatures on this planet are so fiercely hot that its crust is completely molten, featuring vast oceans of glowing lava. Because this planet is highly enriched with carbon and experiences immense internal pressures, scientists hypothesized that a significant portion of its interior could be composed of thick layers of pure diamond. A world of crystalline gemstone, orbiting silently in the heat of a distant sun. Consider another alien world, known as HD 189733b. To the human eye, this planet would appear as a beautiful, deep cobalt blue dot hanging in space, reminiscent of a peaceful ocean world. However, this serene appearance is profoundly deceptive. The planet is a massive gas giant that orbits dangerously close to its star, causing its atmosphere to reach scorching temperatures. The striking blue color is not caused by water, but rather by an atmosphere laden with silicate particles. The winds on this planet howl at thousands of miles per hour, whipping the silicates through the air so violently that it literally rains shards of molten glass sideways. It is a world of continuous, terrifying glass storms, a stark reminder of how diverse and hostile the environments of the cosmos can be. Let us shift our focus to the bizarre, mind-bending remnants left behind when massive stars reach the end of their lives, starting with neutron stars. When a star that is several times larger than our Sun runs out of fuel, its core collapses under the absolute weight of its own gravity. The collapse is so violent and unstoppable that it crushes individual atoms completely out of existence. Electrons and protons are forced to fuse together, transforming the entire core into a giant, hyperdense ball made almost entirely of neutrons. A neutron star packs an entire solar mass, more than the weight of our Sun, into a sphere that is only about 12 miles in diameter, roughly the size of a human city. The density of a neutron star is completely unimaginable. If you were to scoop up a single teaspoon of neutron star material, that tiny amount would weigh roughly 6 billion tons, equivalent to the weight of a literal mountain on Earth. Because these objects are so incredibly compressed, their gravitational fields are immensely powerful. If you were to drop an object from just a few feet above a neutron star's surface, it would hit the ground at millions of miles per hour due to the extreme gravitational acceleration. Furthermore, many neutron stars spin at blinding speeds, rotating hundreds of times every single second, while blasting intense beams of radiation out into space like cosmic lighthouses. We call these spinning titans pulsars, and their rhythmic ticking serves as a precise metronome for the universe. Even more extreme than a neutron star is the phenomenon of a black hole. When the most massive stars collapse, their gravity is so overwhelming that nothing in the known universe can halt their descent. They crush themselves down past the density of a neutron star, past the size of an atom, until they form a point of infinite density known as a singularity. Around this singularity lies an invisible boundary called the event horizon. This is the ultimate point of no return. Once any object, or even light itself, crosses this threshold, the escape velocity required to break free becomes greater than the speed of light. Because nothing can travel faster than light, absolutely nothing can ever return from the dark interior of an event horizon. If you were to approach a black hole, you would witness space and time warp in profound ways. Because gravity slows down the passage of time, an outside observer watching you fall toward the event horizon would see your movements slow down dramatically. To them, your watch would tick slower and slower, and you would appear to freeze right at the edge of the horizon, fading out of view as the light shifting from your body stretched into longer, redder wavelengths. However, from your own perspective, time would seem to pass normally as you cross the boundary, without noticing any immediate change in the fabric of space. It is only as you drew closer to the central singularity that the immense tidal forces would take over, pulling on your feet with vastly more strength than your head, stretching your physical form into a long, thin strand of atoms in a process astrophysicists literally refer to as spaghettification. Let us ponder the vast, quiet voids that exist between the grand structures of the cosmos, known as cosmic voids. When we look at maps of the universe on the largest possible scale, we see that galaxies are not scattered randomly through space. Instead, they are arranged in an intricate, interconnected web of filaments, looking very much like the neural pathways of a colossal brain. These bright filaments are packed with billions of galaxies and trillions of stars. However, between these densely populated walls of matter lie immense expanses of absolute nothingness. These are the cosmic voids, gargantuan bubbles of empty space that can span tens of millions of light years across. Imagine traveling through one of these profound voids. You could journey for millions of years in every direction without encountering a single star, a single planet, or even a solitary atom of gas. It is a level of isolation and emptiness that defies human comprehension. If you were positioned in the absolute center of one of the largest known voids, you would look out into the night sky and see nothing but total uniform blackness in every direction. The nearest galaxies would be so far away that their light would be far too faint to detect with the naked eye. These voids are the quietest, most peaceful places in existence, untouched by the chaotic interactions, collisions, and energetic outputs that define the busier regions of the universe. Within these vast structures, anomalies exist that continue to puzzle the greatest minds in physics. One such mystery is the famous cosmic microwave background cold spot. When scientists meticulously mapped the temperature of the primordial light left over from the Big Bang, they discovered a large region of the sky that is significantly colder and emptier than the standard cosmological models predict it should be. This cold spot is an immense area spanning hundreds of millions of light years across, where matter seems to be inexplicably sparse. It stands out like a giant, mysterious blemish on the otherwise uniform snapshot of the infant universe. Scientists have proposed several fascinating theories to explain this cosmic anomaly. Some suggest that it is simply an incredibly large supervoid, a region of space that happens to be completely drained of galaxies. Others wonder if it could be the result of a statistical fluke, an unusual but natural variation in the early plasma. But one of the most provocative and exciting hypotheses is that the coal spot could be a footprint left behind by a collision with another universe. This theory proposes that our universe is just one of many bubbles floating in a vast, infinite multiverse, and that a neighbouring universe may have gently bumped into ours during the earliest moments of creation, leaving a permanent gravitational bruise on the fabric of our night sky. Let us now reflect on the concept of cosmic time and the absolute slowness with which the universe alters its shape. When we look up at the night sky, it feels completely static, enduring, and immutable. The constellations we see tonight are the exact same patterns that our ancient ancestors observed thousands of years ago, but on a cosmic timescale, everything is in a constant state of fluid motion and transformation. Galaxies are continuously drifting through the dark, pulled by the invisible currents of gravity. Entire stellar systems are circling galactic centers at hundreds of thousands of miles per hour, yet because the distances involved are so staggeringly immense, these rapid movements appear completely frozen to our short-lived human eyes. Consider our own cosmic neighborhood, the Milky Way. Right now, our galaxy is on a direct collision course with our nearest massive neighbor, the Andromeda Galaxy. Andromeda is a magnificent spiral galaxy, currently located about 2.5 million light-years away from us. It is hurtling toward us through the darkness at a speed of roughly 70 miles per second. Despite this incredible velocity, the distance between us is so vast that the two galaxies will not actually meet for another 4 billion years. Over the course of the next few eons, an observer on Earth would watch Andromeda slowly grow larger and more detailed in the night sky, eventually dominating the evening heavens with its spectacular glowing core and sweeping spiral arms. When the collision finally begins, it will be a slow, majestic dance of cosmic proportions. The two galaxies will pass right through each other, their immense gravitational fields pulling and stretching great streams of gas, dust, and stars into beautiful new configurations. Surprisingly, because stars are separated by such immense distances of empty space, it is highly unlikely that even a single pair of stars will actually collide with one another during this monumental event. The entire process will take hundreds of millions of years to settle down. Eventually, the Milky Way and Andromeda will completely merge together, combining their billions of stars to form a single, massive, smoothly shaped, elliptical galaxy that astronomers have already named Milky Way. Let us continue our quiet reflection on the spectacular interactions that shape our universe over unimaginable stretches of time. While the gradual merging of the Milky Way and the Andromeda Galaxy represents a monumental structural shift, the cosmos also contains places where space and time behave in ways that challenge our fundamental understanding of reality itself. Think about the incredible environments that exist around the supermassive black holes located at the centers of most large galaxies. These are not merely passive traps for matter, they are dynamic engines that can influence the evolution of an entire galactic system. As immense amounts of interstellar gas, dust, and stray stars are drawn towards the event horizon by the absolute force of gravity, they do not fall straight in. Instead, because of the conservation of angular momentum, the infalling material begins to swirl around the black hole at extreme velocities, forming a colossal rotating structure known as an accretion disk. Inside this accretion disk, the friction and gravitational forces acting on the matter are so intense that the material heats up to millions of degrees, glowing with a brilliant intensity across the electromagnetic spectrum. It emits vast quantities of X-rays, ultraviolet radiation, and visible light, shining with a luminosity that can completely outshine the combined light of all the billions of individual stars inside the surrounding galaxy. When a supermassive black hole is actively consuming matter and radiating energy at this extreme scale, it is known as a quasar or an active galactic nucleus. It is a striking irony of cosmology that a black hole, an object defined by its absolute darkness, can become the primary source for the most intensely bright and energetic phenomena in the entire universe. The tremendous energy generated within these accretion disks also produces massive jets of highly energetic particles. These cosmic fountains blast outward from the polar regions of the spinning black hole, shooting straight up and down perpendicular to the plane of the rotating disk. These relativistic jets can travel at nearly the speed of light, extending across hundreds of thousands of light years of empty space and penetrating deep into the intergalactic medium. As these high-speed particles crash into the cooler gas clouds surrounding the galaxy, they create immense shockwaves that can heat the gas and blow it away entirely. This process, which astrophysicists call active galactic nucleus feedback, plays a critical role in regulating the birth of new stars. By heating up and clearing away the cold, dense molecular gas clouds that are absolutely necessary for star formation, the central black hole can effectively shut down the growth of its host galaxy, dictating its final size and structure. Let us now move our awareness away from these highly energetic galactic centers to consider the quiet, microscopic foundations that allow all these macroscopic structures to exist in the first place. Think about the fundamental particles that compose every object in the universe, from the smallest grain of sand to the most massive supermassive black hole. For a very long time, scientists believed that atoms were the smallest indivisible building blocks of matter. However, we now know that atoms are complex systems, composed of a dense central nucleus made of protons and neutrons, surrounded by a cloud of orbiting electrons. Going even deeper into the subatomic realm, physicists discovered that protons and neutrons are themselves composed of even smaller, more fundamental entities called quarks. These subatomic particles are held together by the fundamental forces of nature, which operate silently and continuously throughout the cosmos. There are 4 known fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. While gravity is the force we are most familiar with in our everyday lives, directing the orbits of planets and the fall of objects, it is actually by far the weakest of the 4 forces on a subatomic level. The force that holds the atomic nucleus together, preventing the positively charged protons from violently repelling one another, is the strong nuclear force. This force operates over incredibly microscopic distances, acting like an intensely powerful subatomic glue. Without the continuous operation of the strong nuclear force, atomic nuclei could not exist. Matter would instantly disintegrate, and the structured universe we observe would dissolve into a chaotic soup of isolated particles. Let us contemplate the strange and beautiful reality of quantum mechanics, the branch of physics that describes how these fundamental particles behave at the smallest possible scales. In our macroscopic world, objects have definite positions, clear trajectories, and predictable behaviors. If you place a book on a table, you can be entirely certain it will remain there until an external force moves it. But in the subatomic quantum realm, the rules of common sense no longer apply. Particles exist in a state of probabilities, described by mathematical wave functions. A subatomic particle does not occupy a single, specific point in space. Rather, it exists in a fuzzy cloud of potential locations all at the same time, a phenomenon known as quantum superposition. It is only when the particle interacts with its environment or is actively measured that this wave function collapses, forcing the particle to choose a single, definite reality. This probabilistic nature of reality leads to a mind-bending phenomenon known as quantum tunneling. Imagine a ball sitting inside a deep bowl. In our everyday experience, the ball can only escape the bowl if it is given enough physical energy to roll up and over the rim. If it lacks that energy, it is completely trapped forever. But in the quantum world, a subatomic particle can occasionally pass straight through an energy barrier that it does not possess the energy to overcome. Because its position is defined by probabilities, there is a tiny non-zero chance that the particle's wave function extends right through the solid barrier. Occasionally, the particle will simply disappear from one side of the wall and instantaneously reappear on the other side, having tunneled directly through the solid obstacle. This quantum tunneling is not just a bizarre theoretical curiosity. It is a vital mechanism that allows our sun to shine and sustain life on Earth. Deep within the core of the sun, the temperature and pressure are immensely high, forcing hydrogen nuclei to crash into one another. Because these nuclei are all positively charged protons, they experience a powerful electrostatic repulsion that tries to keep them apart. Under classical physics, the core of the sun is actually not hot enough, to give these protons sufficient energy to overcome this electrostatic barrier and fuse together. The only reason nuclear fusion can occur is because of quantum tunneling. Every second, a tiny fraction of the protons inside the sun tunnel straight through the repulsive barrier, allowing them to get close enough for the strong nuclear force to take over and fuse them into helium. This quantum process releases the steady, life-giving light and heat that warms our planet and allows life to flourish. Let us reflect on the concept of antimatter, which sounds like an idea from science fiction, but is an entirely real and verified component of our universe. Every fundamental particle of regular matter has a corresponding antiparticle, an exact twin that possesses the identical mass but carries an opposite electrical charge. For example, the antiparticle of the negatively charged electron is the positively charged positron, and the antiparticle of the proton is the antiproton. When a particle of regular matter encounters its corresponding antiparticle, they undergo a process of total mutual destruction, known as annihilation. The instant they touch, their entire combined mass is completely converted into pure energy, releasing a brilliant flash of high-energy gamma-ray radiation. This is the most efficient energy conversion process possible in physics, transforming 100% of the mass into raw radiation. This absolute annihilation raises one of the most profound and unanswered questions in modern cosmology: the mystery of the baryon asymmetry. According to the standard model of physics, the Big Bang should have produced exactly equal amounts of regular matter and antimatter during the high-energy birth of the universe. If this had occurred, all the matter and antimatter would have completely annihilated one another in the earliest moments of creation, leaving behind a universe filled with nothing but pure uniform radiation and absolutely no physical matter. Yet, when we look out at the modern cosmos, we see a universe made entirely of regular matter. Stars, planets, gas clouds, and humans are all composed of normal atoms, with virtually no naturally occurring antimatter to be found anywhere. Something occurred during the cosmic dawn that created a tiny imbalance, a slight excess of regular matter over antimatter, amounting to just one extra particle of regular matter for every billion pairs of particles. It is from this tiny, fortunate remnant that all the stars, galaxies, and life in the universe were eventually built. Let us guide our thoughts back to the grand cosmic structures, specifically looking at the beautiful variety of galaxies that populate the modern universe. Galaxies are categorized into three main structural types based on their appearance: spiral galaxies, elliptical galaxies, and irregular galaxies. Our own Milky Way is a classic example of a spiral galaxy, featuring a central stellar bulge surrounded by a flat, rotating disk of stars, gas, and dust that is organized into magnificent, sweeping spiral arms. These spiral arms are not solid structures like the spokes of a bicycle wheel. Instead, they are density waves, regions of increased density where matter slows down temporarily as it moves through the galactic disk, much like a traffic jam on a busy highway. As interstellar gas and dust clouds enter these high-density spiral waves, they become compressed, triggering the collapse of the gas and sparking the birth of thousands of brilliant new stars. In contrast to the highly organized and active spiral galaxies, elliptical galaxies look like smooth, featureless spheres or elongated footballs of light. These systems are populated almost entirely by incredibly ancient, low-mass stars that burn their fuel very slowly. Elliptical galaxies contain almost no cold gas or cosmic dust, meaning they have completely lost the ability to form new stars. They are the retirement communities of the cosmos, where star formation has long since ceased, and the existing stellar population is slowly and quietly aging over billions of years. Many of these massive elliptical systems are formed when multiple spiral galaxies collide and merge together, a process that disrupts the orderly spiral arms and consumes the remaining gas reserves in a massive final burst of star formation before settling into a quiet, uniform shape. The third category consists of irregular galaxies, which possess no defined symmetry, central core, or organized structure. These systems often look like chaotic, disorganized splatters of stars and gas against the dark canvas of space. Many irregular galaxies are small dwarf systems that are highly susceptible to the gravitational influences of larger neighbours. When a small galaxy passes too close to a massive spiral or elliptical system, the intense tidal forces can violently pull and distort its shape, tearing away its structure and leaving behind an irregular clump of matter. Despite their chaotic appearance, irregular galaxies are often incredibly rich in coal gas and dust, making them vibrant factories for the rapid and continuous creation of massive, bright young stars. Let us contemplate the existence of satellite galaxies, which are smaller galactic systems that are gravitationally bound to larger host galaxies, orbiting around them much like moons orbit a planet. Our Milky Way is accompanied by dozens of these smaller satellite systems, the most famous of which are the Large and Small Magellanic Clouds. Visible clearly to the naked eye from the southern hemisphere of Earth, these two irregular satellite galaxies look like soft, glowing patches of detached cloud floating in the night sky. They are located roughly 160,000 and 200,000 light-years away from us, respectively. These satellite systems are caught in a permanent gravitational embrace with the Milky Way, and their interactions with our galaxy create powerful physical effects. The gravitational pull of the Magellanic Clouds gently warps the outer edges of the Milky Way's flat disk, while our galaxy's immense gravity is continuously stripping a long stream of gas from the satellites, creating a cosmic trail known as the Magellanic Stream. Over immense stretches of time, many of these small satellite galaxies meet a dramatic fate known as galactic cannibalism. As a satellite galaxy loops around its larger host, it experiences a subtle gravitational drag caused by the surrounding halo of dark matter and stars. This drag gradually robs the satellite galaxy of its orbital energy, causing its path to spiral closer and closer to the center of the host system. Eventually, the smaller galaxy draws so close that the intense tidal forces of the larger galaxy completely tear it apart, shredding its structure and absorbing its stars, gas, and dark matter into the main galactic body. The Milky Way has engaged in this process multiple times throughout its history and is actively consuming several small dwarf galaxies right now, incorporating their ancient stellar populations into our own galactic disk. Let us shift our focus to the immense scales of galaxy clusters, which represent some of the largest gravitationally bound structures in the entire universe. Galaxies are rarely found in complete isolation. Instead, they are drawn together by gravity into groups and clusters. A galaxy group typically contains fewer than 50 galaxies bound together, such as our own local group, which includes the Milky Way, Andromeda, the Triangulum galaxy, and dozens of smaller dwarf satellites. Galaxy clusters, however, are vastly more immense systems that can contain hundreds or even thousands of individual galaxies, all swarming around a common center of mass under the influence of their collective gravity. The environment inside a massive galaxy cluster is incredibly hostile and dynamic. The space between the individual galaxies is not empty. It is filled with an extremely thin, ultra-hot gas, known as the intra-cluster medium. This gas is heated to temperatures of tens of millions of degrees by the immense gravitational energy of the cluster, causing it to glow brightly in the X-ray part of the spectrum. In fact, this invisible, superheated gas contains far more regular matter than all the stars inside all the galaxies of the cluster combined. As individual galaxies hurtle through this dense, hot intra-cluster medium at thousands of miles per hour, they experience a powerful aerodynamic drag called ram pressure stripping. This process acts like a violent cosmic wind, physically blowing the cold gas reserves straight out of the traveling galaxy, leaving a long trail of discarded material behind it and effectively halting any future star formation within that galaxy. Let us now shift our consideration toward the outermost limits of what human eyes and instruments can possibly perceive, exploring the boundary known to science as the edge of the observable universe. When we look deep into the evening sky, there is a fundamental physical barrier to how far our vision can extend. Currently, this boundary is calculated to be roughly 46 billion light-years away from us in every single direction, forming a colossal cosmic sphere of perception. This line is not a physical wall, a solid barrier, or a literal edge to reality itself. Rather, it simply marks the absolute furthest distance that light has been able to travel to reach our instruments since the initial expansion of the Big Bang, taking into account the continuous stretching of space-time along the way. Beyond this boundary of vision, the universe almost certainly keeps going, filled with more structures, gas clouds, and cosmic phenomena. We are simply unable to look at them yet because their light has not had enough time to bridge the immense gulf. Because the expansion of space-time is actively accelerating, many regions of the broader cosmos are currently receding from our vantage point at speeds that exceed the velocity of light. Consequently, the light emitted by those ultra-distant stars will never be able to reach us, even if we were to wait for an infinite amount of time. The observable universe is merely a localized bubble of sight, a small window into a grander, infinite reality that stretches out endlessly beyond our capability to see. Within this visible domain, some of the most spectacular and grand structural displays are driven by active galactic nuclei. At the literal core of almost every large galaxy sits a supermassive black hole containing millions or billions of times the mass of our Sun. Under certain conditions, as immense reservoirs of interstellar gas and dust spiral downward toward the event horizon, a portion of that infalling matter manages to evade being swallowed. Instead of slipping past the point of no return, this material gets caught in intensely compressed magnetic fields and is violently channeled away from the black hole's poles, blasted outward in narrow, ultra-focused, relativistic streams. These immense fountains of plasma travel at nearly the speed of light and can extend far out into the intergalactic wilderness, reaching lengths of multiple millions of light years. When we look at the cosmos using radio telescopes, these structures glow with immense brightness, revealing massive, billowing lobes of radiation at the tips of the jets. Systems that display these features are known as radio galaxies, and their plasma streams represent some of the single largest continuous structures found anywhere in existence. It remains an extraordinary paradox of nature that the most expansive, energetic outflows of matter are manufactured by the regions immediately surrounding black holes, the very objects from which light itself cannot escape. As we bring our thoughts closer to home, inside the familiar rotating disk of our own Milky Way, we find individual stars that completely defy the standard motions of their stellar neighbours. The vast majority of the hundreds of billions of stars in our galaxy travel in an organised collective fashion, circling the central core in a direction dictated by the original rotation of the primordial gas cloud that built the Milky Way. However, astronomers have located anomalous wanderers, such as a specific star designated as H04375439, which travels in the exact opposite direction. This star occupies a retrograde orbit, moving against the collective flow of galactic traffic like a lonely salmon swimming upstream through a swift river. There are a few compelling explanations for how a star could find itself on such an unusual path. It is highly possible that this star originally belonged to a completely separate, dwarf satellite galaxy that was torn apart and absorbed by the Milky Way eons ago. Its retrograde trajectory is simply a lasting signature of that extinct galactic system. Alternatively, it may have experienced a violent gravitational encounter with a dense star cluster or the supermassive black hole at the galactic center, receiving a powerful slingshot kick that completely flipped its orbital pathway. It stands as a gentle illustration that even within the immense clockwork precision of a galaxy, unique outliers forge their own paths through the dark. In addition to containing unique stars, the central heart of our galaxy possesses a surprisingly rich and unexpected chemical signature. When astronomers utilize sensitive radio telescopes to analyze the molecular composition of a colossally dense cloud of interstellar dust located near the galactic center, they identified a distinct organic compound known as ethyl formate on our own planet. This specific chemical molecule is directly responsible for giving raspberries their distinct sweet flavor and providing rum with its characteristic rich aroma. Naturally, this does not imply that the center of the galaxy is literally fragrant, as the harsh vacuum of space is completely devoid of air and cannot transmit sense to a human nose. However, the discovery of these complex molecules highlights the intricate, highly advanced organic chemistry occurring continuously within the cold depths of interstellar space. Deep space clouds are filled with various alcohols, simple sugars, and molecular precursors to amino acids. While these drifting chemical compounds do not constitute life themselves, they are the fundamental raw materials that life requires to emerge. The building blocks of biological systems are floating silently in immense abundance between the stars, waiting to be integrated into future planetary worlds. Let us ponder the deep spatial relationship between our own galaxy and its nearest giant neighbour, the Andromeda Galaxy. Andromeda is a magnificent spiral system located roughly 2.5 million light-years away, and it is currently on a direct, unyielding collision course with the Milky Way. While the literal merger of their primary stellar disks will not take place for approximately 4 billion years, there is a fascinating sense in which the collision has already initiated. The visible stars of a galaxy represent only its bright central core. Surrounding this structured disk is a colossal, invisible halo, composed of highly diffuse superheated gas and vast reservoirs of dark matter. Recent space telescope observations have revealed that the immense outer halos of both the Milky Way and Andromeda are so large that they are already touching, intermingling, and overlapping across the dark intergalactic gulf. Long before the individual stars begin their orbital dance, the invisible boundaries of our cosmic homes are already sharing space, serving as an early prelude to the grand structural unification that will eventually redefine our local night sky. As we look at the universe on its largest possible scales, we find that the grand distribution of matter follows an intricate, web-like architecture. Galaxies are not scattered aimlessly or uniformly across the void. Instead, they are drawn by gravity into long, thread-like strands known as galactic filaments. These immense filaments wind across billions of light-years of space, framing giant, empty bubbles of absolute nothingness called cosmic voids. This vast, interconnected network is referred to by astronomers as the cosmic web. What is profoundly striking about this large-scale structure is that when you observe it from an immense distance, it bears an uncanny structural resemblance to a neural network, precisely like the intricate pathways of neurons and axons found inside a human brain. The dense clusters where thousands of galaxies gather act like neural nodes, while the long filaments connecting them mirror the axons that transmit information. While this structural similarity is completely coincidental, as the universe is not a thinking entity and is governed by entirely different physical forces, it remains a beautiful poetic realization that the largest known pattern in the cosmos looks nearly identical to the physical structure that allows us to contemplate it. Let us listen closely to the subtle, hidden phenomena occurring inside the stars themselves. Although we are taught that space is a complete vacuum where sound waves cannot travel due to the lack of an atmospheric medium, stars are far from silent. Within their deep interiors, the continuous churning of superheated plasma creates profound, low-frequency pressure waves and acoustic vibrations. These internal sound waves travel through the star's gaseous layers like seismic waves moving through the crust of a planet, causing the surface of the star to subtly pulse, expand, and contract. Astronomers can detect these rhythmic oscillations by carefully monitoring microscopic fluctuations in a star's brightness and surface movement. This specialized field of astrophysics is known as asteroseismology, which literally translates to the study of stellar quakes. Every individual star possesses its own unique set of internal frequencies, creating a distinctive sonic fingerprint determined entirely by its mass, chemical composition, internal structure, and age. By listening to these deep silent symphonies, scientists can effectively peer beneath the opaque surfaces of stars, mapping their hidden depths across light years of empty space. Consider the fascinating reality that certain stars are actually ancient relics that predate the very galaxies they currently call home. Large galaxies are not born as fully formed single entities. Rather, they are constructed incrementally over vast stretches of time through the continuous merger and accretion of smaller stellar systems and gas clouds. Because of this evolutionary process, individual stars can easily possess ages that are significantly greater than the modern structural configuration of their host galaxy. These primordial stars originally ignited inside small, primitive dwarf galaxies during the earliest epochs of the cosmos, when those smaller systems were gravitationally drawn into and consumed by larger galaxies. These ancient stars survived the cataclysmic mergers completely intact. Today, they typically reside in the outer halos or within tightly bound spherical systems called globular clusters, orbiting far away from the chaotic galactic centers. Some of these stellar fossils are more than 13 billion years old, making them nearly as old as the universe itself. They carry an incredibly pristine chemical signature, reflecting a primitive era when heavier elements did not yet exist, standing as silent, enduring witnesses to the dawn of cosmic history. While we have come to understand that dark matter is an essential cosmic glue required to hold galaxies together, astronomers have recently encountered profound anomalies that challenge this fundamental rule. According to standard cosmological models, the immense gravitational pull of invisible dark matter is the only reason stars in the outer rims of galaxies can rotate at high speeds without flying off into space. Yet in recent years, meticulous observations have revealed the existence of rare, ghostly galaxies that appear to contain absolutely no dark matter whatsoever. In these unique systems, the stars move at velocities dictated solely by the gravitational pull of the visible matter that we can see. This discovery was completely unexpected and has sent ripples through the theoretical physics community, as it does not fit easily into any established models. Some researchers hypothesize that the dark matter may have been violently stripped away from these galaxies during ancient high-speed collisions with larger clusters. Others wonder if our fundamental understanding of gravity or dark matter is incomplete. These dark matter-free islands of stars remind us that the universe still safeguards profound mysteries, and what we assume to be a universal rule may contain breathtaking exceptions. Let us turn our awareness to our own local star, the Sun, which rings continuously like a colossally large booming bell. Deep within the solar interior, the intense movement of heat creates powerful acoustic pressure waves that ripple through the dense plasma. These sound waves continuously bounce between the Sun's core and its outer atmospheric layers, setting the entire star into a state of subtle, unending acoustic vibration. These solar sound waves are completely below the range of human hearing, operating as incredibly low, slow frequencies. By utilizing specialized spacecraft and instruments, scientists can measure these oscillations on the solar surface through a science called helioseismology. By tracking how these sound waves travel and resonate through the plasma, researchers can construct highly detailed maps of the Sun's internal mechanisms, measuring its hidden density profiles, internal rotation speeds, and deep rivers of hot gas. In this manner, the Sun acts as a massive, beautifully tuned musical instrument that plays a continuous silent song, providing us with the precise insights needed to comprehend the hearts of stars across the wider cosmos. Let us direct our quiet focus to the incredible reality of cosmic distances, which are so immensely vast that they force us to alter our understanding of time itself. When we look up at the celestial objects in the night sky, we are not seeing them as they exist in the present moment. Instead, we are looking backward through time, catching a glimpse of how those objects appeared in the distant past. This phenomenon happens because light, despite being the fastest moving entity in the known universe, still travels at a finite velocity of roughly 186,000 miles per second. Because the space separating cosmic bodies is so staggeringly expansive, it takes a significant amount of time for starlight to cross the empty gulf and reach our eyes on Earth. When you look up at our moon on a clear night, you are seeing it as it existed 1.3 seconds ago, because it takes that long for sunlight reflecting off the lunar surface to reach us. When you look at the Sun during the day, you are viewing light that left its blazing surface 8 minutes and 20 seconds in the past. If the sun were to suddenly stop shining right now, we would continue to see it completely normally in our sky for over 8 minutes before the darkness reached our planet. Moving out into deep space, the scales grow exponentially larger. The nearest star system to our Sun, Alpha Centauri, is located about 4.4 light years away, meaning the light we see from it tonight has been traveling through the dark void for more than 4 years. When we use advanced space telescopes to photograph incredibly distant galaxies located billions of light years away, we are looking at light that began its epic journey when the Earth itself did not even exist. In this way, the night sky acts as a literal time machine, allowing us to view the living history of the cosmos simply by looking upward into the dark. Let us contemplate the extraordinary phenomenon of runaway stars, which are stellar wanderers that have been violently ejected from their homes and are hurtling through the empty void of space at terrifying speeds. Most stars reside within the structured boundaries of galaxies, orbiting peacefully around a common galactic center alongside billions of their neighbors. However, occasionally a star will experience a dramatic gravitational disruption that permanently breaks these galactic bonds. This rejection often happens within binary star systems, where two stars orbit closely around one another. If one of these stars reaches the end of its life cycle and explodes as a violent supernova, the sudden loss of mass can instantly release the surviving companion star from its orbital path, causing it to shoot away into deep space like a stone released from a slingshot. An even more extreme mechanism for creating these stellar outcasts involves the supermassive black hole positioned at the center of our galaxy. If a binary pair of stars wanders too close to the immense gravitational field of the central black hole, the tidal forces can pull the system apart. While one star is captured by the black hole and dragged into a tight, permanent orbit around it, the second star receives an enormous boost of gravitational kinetic energy. This interaction flings the surviving star away from the galactic center at speeds exceeding millions of miles per hour. These hypervelocity stars travel so incredibly fast that they possess enough energy to completely overcome the gravitational pull of the entire galaxy. They are doomed to leave the Milky Way forever, crossing the outer boundaries of our galactic home and embarking on an endless, isolated journey through the absolute dark and emptiness of intergalactic space. Let us reflect on the beautiful and intricate life cycle of cosmic dust clouds, which serve as the primary nurseries for the creation of new worlds. When we look out at the dark patches that interrupt the glowing bands of the Milky Way, we are viewing immense nebulae composed of cold interstellar gas and microscopic dust particles. These dust grains are not like the household dust we encounter in our everyday lives. Rather, they are composed of complex silicates, carbon compounds, iron grains, and microscopic coatings of water ice, all manufactured inside the cooling atmospheres of aging stars and scattered across space by ancient supernova explosions. Within the freezing, dense cores of these molecular clouds, the absolute force of gravity operates silently over millions of years, slowly pulling the diffuse material closer together. As a specific pocket of gas and dust begins to collapse under its own weight, it draws in more surrounding material, causing it to spin faster and flatten into a rotating structure known as a protoplanetary disk. At the absolute center of this spinning structure, the density and temperature rise to extreme levels until nuclear fusion ignites, birthing a brand new star. Meanwhile, in the cool outer regions of the disk, the remaining dust grains begin to collide with one another. Through a process of gentle accretion, these tiny grains stick together to form larger clumps, gradually growing from pebbles into rocks, then into asteroids, and eventually coalescing into fully formed planets, moons, and comets. Every solid object we can touch on our own world, from the deepest bedrock to the physical structures of our own bodies, began its existence as a microscopic grain of dust floating inside a dark, freezing interstellar cloud. Consider the remarkable existence of rogue planets, which are dark, solitary worlds that float completely alone through the deep night of space without orbiting any parent star. In our traditional understanding of planetary systems, planets are tightly bound to a central sun, relying on its gravitational stability and life-giving warmth to define their environments. However, the early stages of planetary formation are incredibly chaotic and unstable, as multiple giant planets develop in close proximity within a young protoplanetary disk. Their gravitational fields continuously tug and pull on one another, creating highly erratic orbital pathways. During these violent gravitational interactions, a smaller planet can easily be kicked out of the system entirely. If a developing planet passes too close to a massive gas giant like Jupiter, the resulting gravitational slingshot can launch the smaller world away from its parent star at speeds that exceed the escape velocity of the system. Once ejected, this world becomes a cosmic orphan, entering a state of permanent isolation as it drifts endlessly through the vast empty spaces between the stars. Because these rogue worlds are completely cut off from the warmth of a star, their atmospheres freeze solid, encasing the planets in total darkness and absolute cold. Yet scientists calculate that there could be billions of these lonely wanderers drifting through our galaxy, vastly outnumbering the stars themselves. Some models even suggest that deep beneath their frozen surfaces, geothermal heat from radioactive decay could potentially maintain liquid oceans, raising the fascinating possibility that life could exist on a world that has never known a sunrise. Let us turn our thoughts toward the majestic and colossal structures known as superbubbles, which are giant cavities carved directly into the interstellar medium of a galaxy. The space between the stars is filled with a thin mix of gas and dust, but this material is continuously reshaped by the energetic actions of massive stars. When a large cluster of hyper-bright, massive stars forms within a molecular cloud, they release incredibly powerful stellar winds, which act as continuous streams of high-velocity particles, pushing against the surrounding gas. As these short-lived stellar titans reach the end of their lives, they detonate one after another in spectacular supernova explosions, releasing immense shockwaves of energy into the surrounding space. When multiple supernovas occur within the same localized star cluster over a few million years, their individual blast waves combine to create a singular expanding shock front. This combined energy sweeps away the interstellar gas and dust like a colossal snowplow, carving out a giant hot bubble that can span thousands of light years across. The interior of a superbubble is filled with an ultra-thin, superheated gas that glows in the X-ray spectrum, while its outer edges form a dense, cool shell of compressed material. As this expanding shell plows into the surrounding interstellar medium, the compression of gas can trigger a secondary wave of star formation, birthing a new generation of stars along the perimeter of the cavity. These immense structures demonstrate how the deaths of ancient stars can directly shape the physical architecture of a galaxy, creating the very environments required to spark new life. Let us ponder the profound mystery of the cosmological principle, which is the foundational assumption that guides our entire understanding of the modern universe. This principle states that when we observe the cosmos on its grandest possible scale, matter is distributed completely evenly and uniformly throughout space, meaning that the universe looks essentially the same no matter where you are positioned or which direction you choose to look. This concept is divided into two main attributes: homogeneity, which means the average density of the universe is consistent everywhere, and isotropy, which means the universe displays no preferred orientation or unique landmarks. On a localized scale, the universe appears highly uneven and varied, featuring dense concentrations of matter like planets, stars, galaxies, and massive clusters separated by vast stretches of empty space. But when you zoom out to an unimaginable scale spanning billions of light years, these individual structural variations smooth out completely, looking much like the individual threads of a giant canvas blending into a smooth, uniform fabric. This large-scale uniformity implies that our position in the cosmos is completely ordinary and unexceptional, and that the fundamental laws of physics we discover locally on Earth operate identically across the entire infinite expanse of existence. It is a comforting realization that the rules of nature are stable and universal, binding the entire cosmos together into a singular, predictable system. let us contemplate the extraordinary phenomenon of gravitational waves, which are actual ripples in the very fabric of space-time that travel across the universe at the speed of light. First predicted by Albert Einstein in his general theory of relativity over a century ago, these waves are generated whenever massive cosmic objects undergo rapid and violent acceleration. When two intensely dense objects, such as a pair of neutron stars or binary black holes, are caught in a tight orbital dance, their movements warp the geometry of space-time around them. As they spiral closer and closer together, they radiate energy outward into the cosmos in the form of gravitational radiation, causing space itself to physically stretch and compress. For decades, these ripples remained entirely theoretical because they are incredibly minute by the time they reach our planet, altering the distance between objects by a fraction of the width of a single atomic nucleus. However, in recent years, scientists constructed immensely sensitive instruments known as laser interferometers, which utilize precise laser beams bouncing down miles of vacuum tubes to detect these microscopic distortions. When two massive black holes collide billions of light years away, the cataclysmic event releases a burst of gravitational waves that washes over the Earth, subtly flexing the space around us. By measuring these waves, we can actually hear the violent interactions of the dark universe, opening up an entirely new way of observing the cosmos that does not rely on traditional starlight or electromagnetic radiation. Let us direct our quiet focus to the incredible timeline of the deep future, looking at the slow and gentle progression of our universe as it moves past its current youth. We are presently living in a very unique period of cosmic history, an era overflowing with vibrant star formation and dynamic galactic activity. However, this high-energy phase will not last forever. As the billions of years roll smoothly forward, the raw materials that allow galaxies to forge new stars will inevitably begin to decline. The immense clouds of cold hydrogen and helium gas that populate the interstellar medium are continuously consumed by successive generations of stars, while massive stars return a portion of their material to space when they die in spectacular supernova explosions. A significant amount of that matter remains permanently locked away inside the ultra-dense remnants they leave behind, such as white dwarfs, neutron stars, and black holes. This gradual depletion of gas means that the overall rate of star formation across the cosmos will slowly but steadily begin to decelerate. Galaxies will find it increasingly difficult to spark the creation of massive, brilliant blue stars, which require enormous reservoirs of dense matter to ignite. Consequently, the night sky will gradually begin to shift its color palette. The bright, energetic blue light that defines the arms of active spiral galaxies will slowly fade away, replaced by the deep, warm, and gentle orange and red hues of long-lived, low-mass stars. This transition marks the beginning of a prolonged quiet twilight for the cosmos, a period where the universe slowly settles into a much more stable, calm, and peaceful state of existence. Consider the immense longevity of the smallest stars in the universe, known to astronomers as red dwarfs. These diminutive stellar bodies possess only a small fraction of the mass of our Sun, but their small size gives them an extraordinary advantage when it comes to survival. Because their internal gravitational pressures are much lower than those of larger stars, they burn through their core reservoirs of hydrogen fuel at an incredibly slow and economical pace. Furthermore, unlike massive stars that only consume the hydrogen located in their central cores, red dwarfs are fully convective. This means that hot plasma continuously circulates throughout the entire body of the star, constantly moving fresh hydrogen from the outer layers down into the nuclear furnace at the core. Because of this highly efficient circulation system, a single red dwarf star can continuously shine and maintain its stable output for trillions of years. This duration is so vast that it completely dwarfs the current age of our universe, which is a mere 13.8 billion years old. Long after our Sun has exhausted its fuel, shed its outer layers, and cooled into a silent white dwarf, these small red stars will continue to glow softly in the deep night. They will become the primary sanctuaries of warmth and stability in the future universe, acting as enduring lanterns that will guide the cosmos through its long, slow transition into the deep eons of time. Let us contemplate the inevitable era when the very last stars in the cosmos will finally exhaust their nuclear fuel and go out. This future epoch is described by astrophysicists as the degenerate era. By the time the universe reaches this stage, new star formation will have completely stopped everywhere because the supply of free interstellar gas will be entirely exhausted. The only remaining stellar objects will be the cold, dead remnants of previous generations of stars. The universe will be populated primarily by white dwarfs, neutron stars, and black holes, all drifting silently through the vast, dark, expanding voids of space. During this incredibly prolonged era, the primary source of illumination in the cosmos will be the very slow, residual cooling of white dwarfs. When a star like our Sun dies, it leaves behind an Earth-sized core of carbon and oxygen that retains an immense amount of leftover thermal energy. Because space is an exceptional insulator, a vacuum with almost no matter to conduct heat away, these white dwarfs can only lose their thermal energy by slowly radiating it away into space in the form of light. This cooling process takes hundreds of billions of years to complete. As a white dwarf slowly loses its heat, its light will gradually shift from a bright white to a gentle yellow, then to a deep orange, and eventually to a faint, barely perceptible red glow. Ultimately, it will lose all its remaining thermal energy, becoming a cold, completely dark lump of carbon and oxygen known as a black dwarf, floating invisibly in the total darkness of an expanding universe. Let us guide our awareness toward the immense and absolute role that black holes will play during the furthest reaches of cosmic time. Once the degenerate era concludes and the final cold stellar remnants have completely decayed or been swallowed up, the universe will enter what scientists call the black hole era. In this incredibly distant future, regular matter as we know it will largely cease to exist in an organized form. The dominant structures left in the cosmos will be supermassive black holes, which will have grown to gargantuan proportions by devouring entire galaxies and clusters over trillions of years. These colossal entities will rule over an incredibly vast, empty and dark universe. Because the expansion of space will have long since pushed all galaxies completely out of sight of one another, each supermassive black hole will exist in absolute total isolation, surrounded by an infinite abyss of nothingness. Yet even these absolute titans of gravity are not entirely immortal. According to the principles of quantum mechanics discovered by Stephen Hawking, black holes are not completely black. They slowly leak energy over time through a process known as Hawking radiation. This phenomenon occurs right at the boundary of the event horizon, where quantum fluctuations continuously create pairs of virtual particles. Occasionally, one particle falls into the black hole, while the other escapes into space, effectively robbing the black hole of a tiny fraction of its mass. This process of evaporation is incredibly slow for supermassive black holes, requiring a duration of time that defies human comprehension, often estimated in the range of 10 to the power of 100 years. For an unimaginably long period, the black hole will slowly lose its mass, particle by particle, radiating a faint, cold stream of energy out into the void. As the black hole grows smaller, the rate of evaporation begins to accelerate dramatically. In its final moments, the black hole will lose the remainder of its mass all at once, ending its multi-trillion-year existence in a sudden, brilliant flash of high-energy gamma radiation. With the disappearance of the final black hole, the universe will lose its last dynamic engines of energy, transitioning into a permanent state of absolute stillness. Let us ponder the final physical state of our universe, an ultimate epoch known to science as the heat death or the big freeze. Once the final black holes have completely evaporated into the void, the cosmos will enter a state of maximum entropy. The universe will have expanded to such a colossal size that regular matter will be completely and utterly diluted. There will be no stars, no planets, no black holes, and no complex structures of any kind remaining. The entire cosmos will consist of nothing more than a highly diffuse, incredibly thin soup of elementary particles, mostly isolated electrons, positrons, and low-energy photons, drifting endlessly through an infinite cold and dark expanse. In this ultimate era, the temperature of the entire universe will drop uniformly to a fraction of a degree above absolute zero. Because everything will be at the exact same temperature, there will be no thermal gradients, no movement of heat, and absolutely no way to extract useful energy to perform work. Time itself will lose its practical meaning, as no macroscopic changes, events, or interactions will ever occur to mark its passage. It is a state of absolute, unchanging equilibrium, a permanent and profound peace that will endure for eternity. The universe will have completely run its course, shifting from a hot, chaotic, and high-energy explosion into a quiet, infinite, and perfectly still ocean of absolute tranquility. Let us bring our awareness back from these unfathomably distant futures, returning our thoughts to the beautiful, vibrant, and alive universe that we currently inhabit. Reflect on the profound realization that you are an active, conscious participant in this grand cosmic story. The very same atoms that compose your body, the carbon in your DNA, the iron in your blood, and the oxygen you are breathing in right now, were forged billions of years ago inside the intense nuclear furnaces of ancient stars, and scattered across space by spectacular supernova explosions. You are not a separate entity looking into the universe from the outside. You are a direct living piece of the universe itself that has developed the capacity to look back, contemplate its own origins, and marvel at its own vast beauty. As you lie here in the quiet comfort of your room, allow the immense scale, order, and peaceful rhythm of the cosmos to wash over you. Realize that all the individual worries, stresses, and anxieties of your daily life are incredibly small and brief when viewed against the timeless, enduring background of the stars. The universe has been expanding smoothly and quietly through the darkness for 13.8 billion years, moving according to elegant, immutable laws that maintain balance and order on a grand scale. You can safely let go of your need to control things, release your tension, and trust yourself to the steady, calm, and enduring currents of existence. Your breathing can become slow, deep, and perfectly rhythmic, matching the silent, gentle pacing of the night sky. Let your consciousness drift gently into the deep truth that the cosmos is not merely an external theatre that you look at, but rather an expansive reality that lives completely inside of you. Every heavy atom in your physical form, the calcium providing structure to your bones, the iron circulating through your veins, and the oxygen filling your lungs with every calm breath, was manufactured inside the high-energy nuclear furnace of a massive star that lived and perished eons ago. We are all made of genuine stellar material, a literal method for the cosmos to explore, observe, and comprehend its own majestic nature. As you rest quietly in the stillness of this moment, let your mind completely let go of the hectic schedules, the endless list, and the complicated anxieties of our everyday terrestrial world. Feel yourself supported by the immense, predictable, and comforting rhythms of a universe that has been expanding smoothly and quietly through the deep darkness for over 13 billion years. There is a profound sense of peace that comes from realizing how beautifully integrated we are with the grand architecture of space and time. Think about the ancient, traveling starlight that is currently moving across the immense void of space, having journeyed for millions of years to reach our planet. That light is carrying the living history of distant worlds, silent nebulae, and evolving galaxies, bathing the Earth in a faint, continuous shimmer of cosmic memories. You do not need to struggle, accomplish anything, or seek answers right now. The elegant physical laws that govern the orbits of massive planets, the rotation of giant galaxies, and the life cycles of stars are operating perfectly and automatically, maintaining a deep and enduring balance across the infinite expanse. You can safely release your hold on the waking world, allowing your thoughts to dissolve into the soft velvet dark of the night sky, drifting peacefully like a single particle of dust floating between the stars. Allow your physical body to relax completely, matching its internal rhythm to the slow, steady pacing of the cosmos. Your breathing can become deep, effortless, and rhythmic, mirroring the quiet expansion of space-time itself. There is an absolute, unwavering tranquility waiting for you in the vast spaces between the stars, a place untouched by time, noise, or distraction. Let your awareness soften as you imagine looking down on our beautiful, fragile blue planet from an immense distance, watching it spin silently in the protective embrace of the dark solar system. We are all traveling together on this small oasis of life, moving safely through an ocean of stars, safely guided by the unseen currents of gravity and time. You are completely safe, completely at rest, and completely free to let your mind drift away into the deepest, most rejuvenating slumber. The immense story of the universe is a narrative of continuous transformation, shifting from blinding heat and chaotic energy into an era of structured beauty, and eventually into a long, peaceful, and eternal twilight. Every stage of this cosmic journey carries its own unique form of wonder and stillness. As you move closer to the edge of sleep, carry with you the faint, comforting realization that you are never truly alone or disconnected from the reality around you. The same energy that ignited the very first stars and drove the expansion of the early universe is the energy that sustains your life and fuels your thoughts. You are an essential thread in the grand, ever-unfolding tapestry of existence, a small but vital piece of a beautiful, glowing universe that exists not just high above your head, but deep within the absolute center of your being. If your mind is still lingering softly in the twilight state between waking and sleeping, let it focus on the pure simplicity of the silence around you. The busy world has quieted down, leaving you in a safe, dark sanctuary where your only task is to rest and recover. The stars outside your window are shining down with an enduring, patient light that has witnessed the rise and fall of countless generations, standing as silent guardians of the deep night. Let your thoughts become lighter and more diffuse, separating like a soft mist and floating gently out into the intergalactic void, where there are no burdens, no weights, and no limits. You can trust the dark, you can trust the natural rhythm of your body, and you can trust the quiet universe to keep watch over you as you surrender completely to sleep. The journey we have taken tonight across the grand structures of cosmology, from the incredible mysteries of dark matter and dark energy to the beautiful life cycles of stars and the serene timeline of the deep future, is a direct reminder of the order and beauty that underpins all of existence. Everything is exactly as it should be, moving according to a grand, harmonious design that stretches across trillions of light years and eons of time. Let your heart settle into this profound sense of cosmic harmony, allowing any remaining tension in your muscles to melt away completely. Your eyelids can grow heavy, your muscles can become loose and relaxed, and your mind can slide smoothly into the peaceful, dream-filled currents of a deep, restful sleep. May your dreams tonight be filled with the gentle glow of distant nebulae, the quiet majesty of spiral galaxies, and the absolute tranquility of the infinite void. Rest deeply, rest peacefully, and know that you are an eternal child of the stars. Good night, and may you sleep in absolute peace.